Yes, good morning. Good morning, one and all. Yes. See, today we are going to discuss one topic that is trigonometry. The word trigonometry word is familiar for you. Okay. So trigonometry. What is that trigonometry? Can anyone give the explanation for the word trigonometry? Here you have the chapter name trigonometry. We'll say it as trigonometry. What is the meaning of this heading? Can anyone try to give the definition for this heading? Who is ready? Raise your hand. Who is ready to give the meaning for this trigonometry? What is this trigonometry? So by looking the word, we can guess what is this trigonometry. Yes. Who's that? Who is ready to give the answer for that trigonometry? Yes? Hello? No one is there? Yes, trigonometry, very simple students. So trigonometry, in the word only we can observe. Try. What is the meaning of try? Try means three. Okay. So gone. Try gone. Gone polygons. Number of sides. So gons means sides. Metry. Geometry. Geometry. That metron. Metron means. What is that metron? Measurement. So here you just observe. Try in the sense three. Gone in the sense sides. Metry in the sense measurement. Three sides measurement. Three sides in the sense which figure? It is related to triangle. Three sides measurement. Trigonometry is a branch of mathematics which deals with the three sides measurement. It is related to the measurement of the sides. Trigonometry. So trigonometry, trigonometry. Tri means three, gon means sides. Okay, metry means measurement. Three sides measurements. It's related to triangles. So then what is the use of this trigonometry branch? So where we have to use this trigonometry branch? So its use is very large. Okay, use. I'll share one page for you. Just where we can use trigonometry. So how we can use trigonometry for these concepts, that you will understand in the higher classes. Okay. So we'll discuss one more chapter. In the trigonometry part, you have two chapters. First chapter is just a basics of trigonometry, introduction to trigonometry. And in the second chapter, application of trigonometry. So in that application of trigonometry, you will get the idea how can we find out these things using trigonometry. Okay, so see here, the first is height of mountain. How can we find out the height of mountain? Then height of pyramid, then height of temple, height of Qutub Minar. If we standing in front of the Qutub Minar without measuring the Qutub Minar directly, how can we say the height of the Qutub Minar? That this is possible using the trigonometry concept. Okay, so next, width of the river. How can we find out the width of the river? Then distance between the tower and the building. These are the applications of trigonometry. So using trigonometry concept, we can find out these things. Okay, so how can we find out? That we will discuss in the next chapter. So this is the uses of trigonometry. So here we are going to use the concept of triangles only. So here where we can apply the concept of triangle, that we will discuss in the next chapter. Okay. So today in this class we are going to discuss the basics of trigonometry. So today's topic is basics. Just first we have to understand the basic concept of the trigonometry. But here one thing we have to notice, in the basics of trigonometry, we are going to take only right angle triangle. That basics of trigonometry works only for the right angle triangle. Remember, okay? So for the basics of trigonometry, so only we can choose right angle triangle. Okay, now let us start the basics of trigonometry. 1 second, some students are waiting in the lobby. Yes. Yes, everyone know the right angle triangle concept, right? So here we'll take one right angle triangle. Just observe this right angle triangle. It is having three sides, no? Yes. Let us mark this triangle as A, B, C. Okay, let us take this triangle as A, B, C. Right angle at angle B. See here, angle B is 90 degree. If angle B is 90 degree, the remaining two angles are there, no? Angle BAC and angle BCA. So both are acute angles only, no? Yes, angle BAC is acute angle and BCA is also acute angle because sum of the angles of a triangle is 180 degree. In that one angle is already 90 degree, in the sense remaining two angles are acute angles only. So here it indicates that this concept is related to acute angles. So now what we have to do? So other than right angle, now right angle is fixed, angle B is right angle. So we have to mark one angle other than the right angle. Which angle you have to choose? Any one angle you can take. So can I take this one? Yes, I'll take this angle. This marked angle is known as theta. Okay, so here you have to observe one word, theta. It's a Greek letter. Okay, theta. We are going to, how to write theta like this. This is the method to write theta. What is this theta? Theta is just a marked angle. We are going to mark the angle theta. This one is our marked angle. So now I am not going to take this angle. This angle, okay? So we are going to take this as 90 degree and marked angle is angle ACB. You can take this angle also, okay? Now let us observe. If we mark one angle theta, what happens now? Yes. See here, AC is always hypotenuse. Yes, right now AC is always hypotenuse. In a right angle triangle, 90 degree, opposite side for 90 degree is always hypotenuse. This name is fixed. Now we have to give the other two sides. So now for our knowledge, actually these are arms of the right angle triangle. Arms. Arms in the sense sides of the right angle triangle. So this is actually hypotenuse. Opposite side for the 90 degrees always considered as hypotenuse. Now we have to name these two sides based on the marked angle. So how to mark that AB and BC? What is the name actually? So now the marked angle theta is this one, no? So for this opposite side is there, no? That is AB. So this side we have to give the name as opposite. Okay, so which one we have to take it as opposite side? For the marked angle, which side is opposite? That is called as opposite side. Next, which is the last one? BC. BC name, we call it as adjacent. Okay, so here we have to observe the three terms. The three terms are, one is hypotenuse. You all know hypotenuse, that is side opposite to 90 degrees called as hypotenuse. Okay, yes. So then we marked one angle. Which angle? That is theta. So theta is a Greek letter. Okay, theta marked angle is just denoted as theta. How to write theta? In this way we have to write theta. So for this theta, which is the opposite side, for that side we have to give the name as opposite and the remaining side adjacent. Okay. Now I'll consider one more right angle triangle. We'll take one more right angle triangle, that is PQR. You just take PQR right angle triangle, right angled at Q. So here again we'll name this angle hypotenuse. This one is fixed. Hypotenuse is fixed, opposite side for the 90 degree. Now here we mark this angle. The marked angle is this one. Now we'll change the marked angle for this one. Now this is the marked angle. Can you tell me the opposite side now? For this opposite side is QR. Now we have to name this side as opposite side. Okay, next this side as adjacent side. Is that clear, students? How to mark this one? This is the basic of trigonometry. In the basics of trigonometry, we are taking only right angle triangle. Right angle triangle definition is one angle is 90 degree, remaining two angles are acute angles. In that, so angle opposite to 90 degree is always called as hypotenuse, and we have to mark one angle, marked angle we have to choose other than 90 degree. We cannot take 90 degree as a marked angle. Other than 90 degree, we have to mark one angle. On the basis of that marked angle, we have to take that opposite side and adjacent side. See, the opposite side for the theta is called as opposite side, and this one is adjacent side. Here this is theta and this is opposite side and this is adjacent side. Up to this concept clear now, students? Yes. Now, can you write the ratio of the triangle? Yes, not two triangles. We'll take only one triangle now. In a triangle ABC, we are observing three sides. How many ratios we can write? Okay, ratios. How can we write the ratio? AB by BC we can write. AC by BC we can write. Next to AB by AC we can write. Then BC by AC we can write. So then we can take the reverse, no, reciprocal. No? So total ಎಷ್ಟು ರೇಷಿಯೋನ ಬರಿಬಹುದು ನಾವು? ಯಾರು ಹೇಳ್ತೀರಾ ಆನ್ಸರ್? In one triangle ABC, how many ratios can be given? Okay, yes, who is ready to give the answer for this? Hello? No one is ready? See here, in the first triangle ABC, board is visible, no student? Yes, first one. Board is visible? Yes. Better, I'll rub the second figure. Second figure is clear, no students? Yes. Now we don't want this figure. We'll take this one only. ABC is a right angle triangle. So ratios. Oh yes, I got the answer. Ashwit Nayak gave the answer. Yes, 6 ratio. Ashwit, your answer is right. How 6 ratio? See here. AB by AC, 1 ratio. Look at the figure carefully. AB by AC, 1 ratio. Then BC by AC, 1 ratio. BC by AC, 1 ratio. Okay. AB by AC, 1 ratio. BC by AC, 1 ratio. Then which one? AB by BC. This AB by BC, 1 ratio. AB by BC, 1 ratio. Correct, no? Next. Yes, 1 second. See here, AB by AC, 1 ratio, first ratio. Then BC by AC, also 1 ratio. Next to AB by BC is also 1 ratio. Next, can we take the reciprocal of this one? AC by AB we can write. Then AC by BC we can write. Then BC by AB we can write. So can you tell me one more ratio? Is it possible to give one more ratio for this? If you are having one more ratio, you can raise your hands. I'll give the chance to speak. See, just observe the figure. Can we try to write one more ratio in this figure? So now we covered this one. This divided by this. Then this BC divided by this. Then AB divided by BC. Here we covered 3 ratio. Next we took the reciprocals of that one. That is AC divided by AB. Next to AC divided by BC. Then last one is BC divided by AB. So can we give one more ratios? So yes, Shanvi, 3 ratios, not 3 ratios, Shanvi. So actually we can write the 6 ratios. 6 ratios in the form of AB by AC, BC by AC, AB by BC, AC by AB. We can take the reciprocal of the above 3 ratios also, no? Yeah, actually by looking the figure you will give the answer as 3 ratio. But we can take the reciprocal of the first 3 ratio. Now that is also considered as a ratios only. Total 6 ratios we can name in this diagram. Total 6 ratio. Now what is the work is we have to give one beautiful name for these 6 ratios separately. That is actually today's concept. What is this? AB by AC, Mataji name is ready, no? No, not that type. So according to the theta, we have to give name. Now it's a time for the naming ceremony. So AB by AC, we have to give a name for that already. It is given by the mathematicians only. Today we have to discuss that namings, okay? AB by AC. So now this is according to the naming of the ABC triangle. Now we'll write the ratios in the form of these sides, that is opposite, adjacent and hypotenuse. We'll list out the 6 ratios in the form of, okay, sides. So now can I write this one 6 ratios? Yes. We'll start with the sides naming. Okay, first one. First one. AB by AC we covered, no? That is opposite. Opposite divided by hypotenuse. Opposite divided by hypotenuse. First one. So what is the name of this one, opposite by hypotenuse? That we will discuss later. So first we'll discuss this one. Next one is adjacent by hypotenuse. Next one is adjacent by hypotenuse. Okay. Third one is, so opposite by hypotenuse is over. Adjacent by hypotenuse is over. Then opposite by adjacent. Third one is opposite by adjacent. Opposite side by adjacent side. Okay, so these 3 are over. Now I'll give little bit space to write the name for this. I'll write the 4th ratio here. So for 4th ratio, I'll not look into the figure. I'll look at the first 3 ratio. I'll take the reciprocal of that first 3 ratio. What is that? Hypotenuse divided by opposite. 4th ratio is hypotenuse divided by opposite. And 5th one is hypotenuse divided by adjacent. Hypotenuse divided by adjacent. Okay. So then 6th one is adjacent divided by opposite. Adjacent divided by opposite. We covered all the ratios, no? Yes, opposite by adjacent over, adjacent by opposite over, opposite by hypotenuse, hypotenuse by opposite, then opposite adjacent by hypotenuse, hypotenuse by adjacent. So these are the 6 ratios. Okay, we covered the 6 ratios. So what is the name for this data? So what is the name for this? For that I'll share one page. You just look at that figure. Yes, here we have the picture, trigonometric ratios. Now our concept is trigonometric ratios. See here, let us consider one right angled triangle and write the possible ratio of its sides with respect to its acute angle. So here we took one right angled triangle, that is ABC. So here angle is 90 degree B. Here marked angle is this one theta. For that opposite side is called as opposite and this side is called as adjacent and this is called as hypotenuse. Here we took the 6 ratio. See here, a triangle has 3 sides. To write the ratio, numerator can be written in 3 ways and denominator in 2 ways. Both can be written in 3 into 2, 6 ways. So, using the sides of the triangle, we can have 6 different ratios. See here, we got the 6 different ratios. Now, it's time to name that ratio. Here you just observe this table. This table is very, very, very important. If you know this table, then only you can touch the trigonometry problems. Otherwise, so trigonometry is unknown for you. Okay. So first here you just observe opposite by hypotenuse. Here you just observe in the board also opposite by hypotenuse. Trigonometric name of the ratio. Here the second column is trigonometric name. Okay. Then in the third column we can observe short form. Here they took the long form, no? So but for the problem and all we can use this short form only. But we will understand the long form and the short form both at a time. Okay. So what is the name of this? Opposite by hypotenuse. This opposite by hypotenuse is named as sine of angle theta. S-I-N-E sine. Sine of angle theta. So mathematician gave the name for this ratio as sine. S-I-N-E sine. Okay. which is equal to sine sine of angle theta, but short formally, so we use this as sin sine theta. Is that clear, students? Yes, sin in the short form only we are going to take the first three letters only, that is sine theta. Opposite by hypotenuse, which is called as sine theta, or sine theta is nothing but opposite side by hypotenuse side. So ratio of opposite and hypotenuse is called as sine theta. Okay, next one is adjacent by hypotenuse. Look at this second one, adjacent by hypotenuse. What we call for this adjacent by hypotenuse, that is called as cosine of angle theta. Cosine, okay, cosine. We call this as cosine of angle theta. This is a long form, but in the short form, we are going to take this first three letters only, that is COS, just cos theta. We'll name this as cos theta. Okay, so what is that theta? Theta is a marked angle. Okay, first one is opposite by hypotenuse is called as sin theta, and adjacent by hypotenuse is called as cos theta. Got the idea of this two, no? Then third one is opposite by adjacent. Here we have to observe one thing that we will discuss later. Now just we will give the namings. Okay. Opposite by adjacent. Ratio of this opposite by adjacent. What is that name? Tangent. So the name is tangent. Tangent of angle theta. Tangent of angle theta. But we have to use the short form. Only first three letters will take. So tangent of angle theta is denoted as tan theta. First three letter tan theta. T-A-N, tan theta. So got the idea of this three ratio. Opposite by hypotenuse is called as sin theta. Then adjacent by hypotenuse is called as the trigonometric name. So these are the names given by the trigonometric names. Okay, short form. We are going to write the short form. What is the sin theta, cos theta, tan theta? So now three work is over. Now we'll go to the reciprocal of that one. What is the reciprocal? That is first one. Opposite by hypotenuse. Here the fourth one is hypotenuse by opposite. What is that hypotenuse by opposite? Hypotenuse by opposite. See here, hypotenuse by opposite. What is the name of this hypotenuse by opposite is cosecant theta. Here the name is cosecant theta. Cosecant theta. Cosecant of angle theta. Names are really different names, no? Yes, cosecant theta. But here we cannot take the first three letters. Why? Why can't we take the first three letters here? Can you give the answer for this question? Who is ready to give the answer for this question? Yes, here we have Akshay. Yes, Akshay, tell me.
Actually, both are also having first three letters C.
Yeah, if we take here also cos, COS, it forms cos only. Already we gave the name. In one family, only one name, no. So we cannot give same name for the brother. Correct? So that's why already cos theta is there in your trigonometric ratios home. So that's why if we consider here also three letters, we'll get another cos theta. So we cannot give the same name for the two ratios. That's why we'll move further. We'll choose, instead of taking three letters, here we are going to take the 5 letters. Okay. So 5 letters ತಗೊಂಡ್ರೆ ನಿಮ್ಗಲ್ಲಿ ಮತ್ತೊಂದು name pronounce ಮಾಡ್ಲಿಕ್ಕೆ easy ಆಗುತ್ತೆ ಅಂತ ಹೇಳಿ ಏನು ಮಾಡ್ತಾರೆ 5 letters na choose ಮಾಡ್ತಾರೆ, that is COSEC. So in the sense cosec, what do we call for this? Cosec theta. So fourth ratio is cosec theta. So cosec theta ratio is hypotenuse by opposite. So this is the reciprocal of the sin theta. Reciprocal of sin theta is, that is cosec theta. Next, hypotenuse by adjacent. See here, hypotenuse by adjacent. For that name is secant theta. Secant theta. Secant of angle theta. What is that secant of angle theta? That is hypotenuse by adjacent. Here also we have to choose the first three letters. That is sec theta. We'll read it as sec theta. What we read? What we have to read? Sec theta or secant theta. Also you can read. For the reading purpose, you can use secant, cosecant. So, but while writing in the problem, you can use this short form column only. Okay. So, secant theta. Now, the fifth ratio is secant theta. That is sec theta. In the short form, we call this as sec theta. Now, sixth one, adjacent by opposite. What is this adjacent by opposite? That is cotangent theta. Cotangent theta. Cotangent theta. So here also we'll take the first three letters only. So in that we got the word cot. C-O-T, cot. So we'll take this as cot theta. So what we have to take this as cot theta. Now you just observe, students. See, sin theta, cos theta, tan theta, cosec theta, sec theta, cot theta. These are the 6 names given for these 6 ratios. Let us recall once. Sin theta is equal to opposite by hypotenuse. Cos theta is equal to adjacent by hypotenuse. Tan theta is equal to opposite by adjacent. Cosec theta is hypotenuse by opposite. Sec theta is hypotenuse by adjacent. Cot theta is adjacent by opposite. If you know this table, you can easily work out every problems of introduction to trigonometry problem part. Okay, so you have to learn these ratios with their short form. Okay, sine in the sense opposite by hypotenuse. Cos, adjacent by hypotenuse. Tan, opposite by adjacent. Cosec, hypotenuse by opposite. Then sec, hypotenuse by adjacent. Then cot, adjacent by opposite. These are the basic 6 trigonometric ratios. Okay, yes. Now we have to understand some relationships are there in this. What is that relationship? Can anyone try to give the relationship between these 6 ratio? What relationships you are observing in this? Who is ready to give the answer? Raise your hands. We can give some relationship for this. What is this relationship? So here, opposite here, you just observe the picture. Opposite by hypotenuse, adjacent by hypotenuse. Very next, tan theta, we got opposite by adjacent. How we got this opposite by adjacent? Using these two. Can we find out tan theta using these two? Yes, of course. We can write. How can we write? That is tan theta, which is equal to, we can take the ratio as sin theta by cos theta. How the? Really? Sin theta by cos theta, which is equal to cos theta. Now, yes, can we try once? Yes, whether it is right or wrong, we'll see. Tan theta, which is equal to sin theta, opposite by hypotenuse. Opposite by hypotenuse. Divided by cos theta in there, adjacent by hypotenuse. Adjacent by hypotenuse. Tan theta is equal to sin theta by cos theta. So sin theta is opposite by hypotenuse. Next to cos theta is adjacent by hypotenuse. If we have this type of relationship, what we have to do for that? Tan theta, which is equal to, 1 second students, I'll stop sharing. Board is visible now? Yes. See now here, tan theta, which is equal to sin theta by cos theta. We took this relationship, whether it is right or wrong, we are going to verify this one. Tan theta, we are going to write it in the form of sin by cos. Okay. Whether it is right or wrong, we'll see the answer now. Sin theta, we have opposite by hypotenuse. Cos theta, we have adjacent by hypotenuse. Now, in the next step, what we'll get? So, opposite by hypotenuse. Here divided by is there. If we take the reciprocal, then what happens? Into adjacent by hypotenuse. After the reciprocal, it becomes hypotenuse by adjacent. So you all know this method now? Yes. Board is visible now, students? Yes, board is visible? Yes. So now you just observe. Opposite by hypotenuse. Then we took the ratio, reciprocal here. Then it is hypotenuse by adjacent. Then hypotenuse get cancelled. What is remaining now? Opposite by adjacent. So tan theta which is equal to opposite by adjacent. You just observe the answer here. Tan theta is equal to opposite by adjacent, right? Now, yes, can we write tan theta which is equal to sin theta by cos theta? Yes, so tan theta we can write it as sin theta by cos theta. This is the relationship between the six ratios. Now, can you tell me the one more relationship here? So we got one relationship here. What is that? Tan theta is equal to sin theta by cos theta. So meeting will end in 5 minutes. We got the message that one. So if we lost the time, then join with the same link for further 10 minutes. Okay, just we'll end up the session by discussing the relationship between the trigonometric ratio. Then remaining concepts we'll discuss in the next class. Okay, students? Yes, now we got the six ratios idea and one relationship. What is that relationship? Tan theta is nothing but sin theta divided by cos theta. Cos theta. Next, can you tell me? Try to tell me one more relationship. Yes, who is ready to give the answer for that? See, students, why you are not participating today? Raise your hands fast. Only Akshay is raising the hands in the class. What about others? Are you all sleeping? Hello? Yes, Soumya Igde. Sumak? Sumak?
No, Mataji.
Sumak, what? No. You don't know? See, like tan theta, you can try one more relationship. No, Sumak? Yes, Vaishnavi? Siri? Yeah, Siri raised the hand. Siri, speak up fast. Siri, which relationship you are observing, Siri? Hello? Yes, Pannaga Hegde. Cosec theta by sec theta equal to cot theta. Yes, very good, Pannaga. I got the answer from Pannaga. That is here. Cot theta is equal to cosec by sec. Can we try that one? Yes, cot theta which is equal to cosec theta divided by sec theta. Whether it is right or wrong, we'll substitute now. So, cosec theta is hypotenuse by opposite divided by sec theta is hypotenuse by adjacent. Okay, so then after simplification, here hypotenuse divided by opposite into after the reciprocal we got adjacent by hypotenuse. Here hypotenuse get cancelled. Remaining is adjacent by opposite. Adjacent by opposite. Right now, yes, cot theta is adjacent by opposite. So we got one more relationship that cot theta which is equal to cosec theta by sec theta. So we got one more relationship. Here we will list out the relationship on the board. First one is tan theta which is equal to sin by cos, that is sin theta by cos theta. Second relationship is cot theta, we can write it as cot theta is equal to cosec theta divided by sec theta. Two relationship we got. So only two relationships, students. Yes, can you try one more? Yes, who is ready to? Yes, who is ready to give the answer for that? Vaishnavi. We'll give the time for Vaishnavi. Vaishnavi, can you tell me one more relationship, Vaishnavi? Yes, tell me, Vaishnavi.
Cos by sin is cot.
Cos by sin is?
Cot.
Cos by sin is cot. Yes. Cos by sin is cot. Yes. Third one, cos theta by sin theta, which is equal to cot theta. Yes, this is also one relationship. See, all these relationships we have to use for the problem part. Okay. So now cot theta we can also write it as cos theta by sin theta. You just check the answer. Cos theta is adjacent by hypotenuse. Sin theta is opposite by hypotenuse. After the simplification, the answer is cot theta, that is adjacent by opposite. Yes, right answer, Vaishnavi. So cot theta is equal to cos by sin. Next one. Only this much. Next. Yes, Akshay.
Cos theta is equal to sin theta divided by tan.
Tan theta. No. Yes. Then only three ratios you are observing. See, you just observe this. Opposite by hypotenuse. Adjacent by hypotenuse. Opposite by adjacent. These are all okay. Now, in the fourth one, what we did actually? We took the reciprocal